So it's just important here that we keep our equations straight and organized. With that, it should be fairly straightforward. So Amy sells her kale at 20. For the first 20 pounds, it's the rate of X. And for the kale after that, it's whatever that amount is, subtracted from 20, times 80% of that full price. Lucia, same thing, different equation, of course. First 14 pounds are sold at X rate. Then the pounds beyond 14 are sold at a slightly higher rate, 90% of her full rate. So we multiply all of them out, and we end up with, and the two that we were trying to figure the point at which they end up breaking even. So we can set the two equations equal to each other. So 20x plus y minus 20 times 0.8x equals 14x plus y minus 14 times 0.9x. One of the things to make this a little bit easier is to notice that, so we have this term here plus this term here, and then this term here plus this term here. Each one of the underlined terms has an x in it. I should just make that a different color. So there's an x here, an x here, an x here, and an x here. The nice thing about this is that we can factor out an x of every single underlined term in here, and the equation remains the same, and now it becomes an equation with a single variable. So now we have 20 plus 0.8 times y minus 20 equals 14 plus 0.9 times y minus 14. So, you know, that's 20 plus 0.8y minus 16 equals 14 plus 0.9y minus 12.6. We can simplify the coefficients, or what do you call it? The constants, that's the word I was looking for. Right, so 0.8y plus 4 equals 0.9y plus 1.4. And we can then figure out that 0.1y equals 2.6 and y equals 26. So the point at which you break even between the two kale sellers is at 26 pounds. Answer choice C.